Okay, so we're going to change the parametric form of a plane to the vector form. Okay, and this is essentially our parametric form, where you take a value for x, x being our variable, and you set it equal to some parameters, a point, a directional vector in form of s, and a directional vector in form of t. So our vector form is, this is some point on our plane, and maybe we should just do a rough sketch of idea of a plane. So here's our plane, let's say, okay, and this x, y, z is a point. We'll call them point P, right? Represented by x, y, and z. Just some point on the plane. What we also have is direction vector s, so we'll call that s, and that is our x, y, s, z, s. I guess we could write it in x, y, s, and z, s. And another directional vector, all right, t. And this is xt, yt, it's a little small here, zt. Okay. What this is here is we're going to change our parametric form into this form here. This is our t. Our t is some directional vector on the plane. S is another directional vector on the plane, and this is some point. Well, we know that we can put these two together, these two planes, okay? And if we need to form a scalar, just kind of jumping ahead, we could find the cross product between the two. That would give us a normal to the plane. And then once we have a normal, we can use that point to kind of find out the scalar version of it. But we need to know how to go from parametric to vector. It's actually really straightforward. Our constants are our point. Okay, so this is our point P all up here. This is our S, okay? And our S coordinates, I guess I'll use purple for that, are these values here. Okay, so they're going to be replacing our xs, ys, and zs. And finally, our t values are these guys here. We still use s and t as our directional vectors. So it's simply just plugging values in. So our coordinate, our x value for the coordinate is 3, our y value is 1, and our z value is 5, that's our coordinate, plus s, directional vector -2 for x, 3 for y, and -1 for z, plus t, and our t values are +2, 1, and -2. Okay. So now that we have st, and I'll just kind of, I won't carry out the steps, but I'll talk about the idea. We find s cross t, and that'll give our normal, and our normal will be perpendicular to our plane, right? So whatever the normal's value are, we're going to call them capital A, B, and C. I've called them that because in the scalar version or the Cartesian version of a plane, we could go 0 is equal to A, once we found the normal, so AX plus BY. So we essentially, again, just plug those values in, plus CZ. And these are only unknown. So once we have a normal, we have our A, our B, and our C. And then from there, our coordinate P are the x, y, and z values. So we can plug coordinate P in for x, y, and z, and then we can solve for D, and then you have the scalar. So you eventually, from our parametric form, you have 3 forms of a plane. You have the parametric form of the plane, which we just converted to the vector. And from the vector, we take the directionals, find the cross product, we have the normal, plug the values in, and we have the scalar. Does that make sense?